Yeah.
So this is that question which we have to discuss. In this question, they are saying the the enthalpy changes for the conversion. Oh, it's okay. So the enthalpy changes for the conversion of the four compounds in the gas phase into their constituents atoms are: when you break water molecule, this amount of energy is needed. When you decompose methane, this amount of energy is needed. When methyl alcohol, this amount of energy is needed. When ethyl alcohol, this amount of energy is needed. Now they are
Yeah.
saying calculate the bond enthalpy of the CC bond, carbon carbon bond. To break this bond, the amount of energy required, we have to find that amount of energy. So let's see how to do. So first we would observe here, here and here, where carbon and carbon bond is present. In the first, is there carbon-carbon bond present? No. Is there carbon-carbon bond present? No. Yes, carbon-hydrogen bond is present. But carbon-carbon bond is not present. Is there carbon-carbon bond present? No. Carbon-carbon bond is not present because there is just one carbon, but here two carbon. So here I can see carbon-carbon bond. Here I can see carbon-carbon bond is present, and this is the structure of this compound. Here carbon-carbon bond is present. So it means we have to think to find this, and because carbon-carbon bond is present here. So okay, so basically now I have to find the bond enthalpy for this bond, carbon-carbon bond. But to find the bond enthalpy for this bond, I need bond enthalpy for carbon-hydrogen bond as well. I need bond enthalpy for this carbon-hydrogen bond as well. I need bond enthalpy for this carbon-hydrogen bond as well. I need bond enthalpy for this carbon-hydrogen bond as well. I need bond enthalpy for this carbon-hydrogen bond. And there is a carbon-oxygen bond, this one. So I need this bond enthalpy. And there is a carbon-hydrogen bond. I need this. Then I can get bond enthalpy for carbon-carbon bond.
Yeah.
So let's see how by using these three I can get bond enthalpy for carbon-hydrogen, carbon-oxygen, oxygen and hydrogen. So in the first example here, water is present. I can write this water like that. When we break this water molecule, we get two hydrogen and oxygen gas, and this amount of energy is given out. So this amount of energy is given out when you break a water molecule having oxygen hydrogen bond, having two oxygen hydrogen bond. When you break water molecule, then this amount of energy is given out.
Yeah.
And this water molecule has how many oxygen hydrogen bond? You would say two. One is this one is this one. So two oxygen hydrogen bond is present. If you want bond energy, bond enthalpy just for one oxygen hydrogen bond,
What
not
by
for
two?
just for 1 by 2. Yeah, so this is for two oxygen hydrogen bond. So you divide this by 2, or you say multiply by 1 by 2, or you divide this by 2. When you divide this by 2, you would get 464 kilojoule per mole. So to break oxygen hydrogen bond, here they have said when you break water 928 kilojoule per mole energy is given out. So you have seen within water molecule there is 2 times oxygen hydrogen bond is present. So to break this bond, you break this bond. Total energy is 928. So for one oxygen hydrogen bond, it means you have to divide 928 by 2.
Yeah.
Okay. Now comes to the next. CH4. 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 So when you break CH4, you get carbon, you get 4 hydrogen, and the amount of energy is 1740. So Mariam, 1740 is the amount of energy needed when you break all the bonds of methane. So if you just want to break one bond of methane, one carbon hydrogen bond, then how
Divide by 4.
very good. Divided by 4, and you divide by 4, it would be 435 kilojoule per mole. So this is carbon hydrogen bond. In few examples they have given energy like that, but here they have not given energy like that. Okay, now comes here CH3 C, then there is OH. So here is H, here is H, here is H. And Mariam, that would give you carbon, 4 hydrogen, oxygen, and amount of energy given out is 2105. So you have carbon hydrogen bond energy here, here. You have oxygen hydrogen bond energy. So here you can get carbon hydrogen bond energy. Sorry, carbon oxygen bond energy. How? So carbon oxygen bond energy would be equal to, this is the total bond energy for this step. Like when all the methyl alcohol, all the methanol molecule decompose, you get 2105 kilojoule per mole energy. Now I have to find just carbon oxygen bond energy. So if I subtract carbon hydrogen bond energy, if I subtract this carbon hydrogen bond energy, if I subtract this carbon hydrogen bond energy, if I subtract oxygen hydrogen bond energy, I can get carbon oxygen bond energy. So carbon hydrogen bond energy. So here I have to write carbon hydrogen bond energy, and this is, you see here, 3 times, because there is 3 times carbon hydrogen, 3 times carbon hydrogen, 3 times carbon hydrogen,
Yeah.
plus there is 1 time oxygen hydrogen. 2105 is the total amount of energy needed to break all the bonds. So carbon hydrogen bond is 435. So 435 times 3. Oxygen hydrogen bond is 464. So when you solve it by using calculator, you have a calculator, just put this
Yeah,
as
1 second.
okay.
2. 336.
336, very good. 336 kilojoule per mole. Now comes to the final. Final is now what this is? This is carbon oxygen bond energy, and final is this one, C2. Here H, here H, here H, here H, here H. So now I have to find this carbon-carbon bond energy. So carbon-carbon bond energy, or say bond enthalpy, would be equals to total. To break all the bonds of ethyl alcohol, I need 3 to 2 amount of energy, minus, so you see carbon hydrogen, how many times carbon hydrogen bond? 1 1 1 1 1. So how many times carbon hydrogen bond here? You say 5.
Yeah.
So 5 times carbon hydrogen bond. Then how many times carbon oxygen bond? 1 time. So carbon oxygen bond 1 time, and oxygen hydrogen bond is 1 time.
Yeah.
Now 332 5 times carbon hydrogen bond. So carbon hydrogen bond, you see carbon hydrogen bond is 435, getting from here. Carbon oxygen bond, you just got from here, 336. Oxygen hydrogen bond, you got from here,
Yeah.
464. Mariam, you just put this at calculator and try to solve it.
347.
347, very good. 347 is carbon-carbon bond enthalpy. So this is, you can write it down if you want. You can write it down. You can